Welcome back to Spice. In this session, we'll discuss about gas chromatograph. We call it as GC. So this is the look and feel. You have this gas supply unit, and you have the sample in and sample out, and you have the injection in it, and you have this column, and you have the detector, and we have a oven. This all in a oven, actually thermostat oven. Then you have this detector wherein the chromatograph, we can see the readings, all these. Okay, basically this is a data system. So we are going to discuss about each and every aspects of this gas chromatograph as a whole. Okay, right. So let's move on. Of course, this one, I wanted to inform you, actually, as part of the quality, measurement and design, I intend to actually do some series of videos on this. And as part of that, in fact, we covered this quality measurement, terms of definition, and components and analysis system. So there was not much, support from your side. So I decided not to proceed further. So instead, I chosen a selective topic. Hope this will be useful for you. So that's why, yeah, I'm uploading this gas chromatography in this aspect. I mean, in this session. Okay, right. So subsequent sessions on this subject will be subject to your liking and yeah, views. Otherwise, there's no point in spending time, effort, all this. Okay, let's go into the subject. Gas chromatograph. So intro. Okay, what is this gas chromatograph? So gas chromatograph, we call it as a GC, or one of the most utilized analyzers as part of process measurements and analysis in the field and in lab. Okay. So GC are one of the most utilized analyzer as part of the process measurement. So this is due to the fact that each GC can be utilized, can be used to analyze different component using different application and with very high level of accuracy. So that is why this is one of the most utilized analyzer. Okay. So can be used to analyze different component using different application with a very high level of accuracy. However, the disadvantage is that unlike continuous analyzer, a GC have a cycle time. This is only one drawback. Means each measurement takes a given period of time, which ultimately results in periodic update. So basically, it's unlike a continuous analyzer. The GC has a cycle time. That's it. That is only the maybe a disadvantage. That's it. Okay, that's about the intro part and few more to add on. GC require additional resources like carrier gas, on continuous basis to do the analysis. Okay, I think this is a typo error. Yeah, carrier gas on continuous basis to do the analysis, as we have seen in the first slide, right? Yes. So a GC, depending upon the application, can analyze both gas and liquid samples. This is a point to note. Can analyze both gas and liquid samples. Sampling system plays an important role for all analyzer. I hope you agree with that, right? Yeah. GC are no exception for that. Okay, sampling system. So because of the ability to measure the trace level measurement, a problem in sample system can evidently affect the analyzer performance. Okay, so problem with the sample system can immediately affect the analyzer performance. So you can understand the importance of sample system. That's it. Good to go. And now we go into the major components. Okay, I'm going to explain with the help of this diagram. Okay, gas supply. Okay, this is the gas supply. As you can see, the gas inlets. So carrier gas is usually helium, hydrogen, or nitrogen. Just very important, friends. Carrier gas is usually helium, hydrogen, or nitrogen. Okay. Then injector part. This one. This injector part. So column inlet or injector. Actually, we call it as column inlet. Inlet to the column, or we call it as an injector, provides a means to introduce a sample into the continuous flow of carrier gas. So basically, this is to introduce a sample into the continuous flow of the carrier gas. Okay, that is the point. Okay, so then column, you have a column, right? Yeah, GC column is the heart of the system. Yeah, of course, and it is coated with a stationary phase which greatly influences the separation of components. Here it is actually coated with a stationary phase which greatly influence the separation of the components. Okay, this is about the column. Just get to know this concept, friends. Gas supply and injector and the column. Okay, right. And in the column, we have two types, packed column and capillary column. Okay, that's it. This is actually a capillary. Right. Then few more to add on. Oven. Okay, this all this thermostated oven. So column is placed in an oven where the temperature can be controlled very accurately over wide range of temperatures. Okay, that is the oven part. Then we have a detector. We have a detector. Number of detectors are used in gas chromatography. There are many numbers of detectors are used in gas chromatography. Many numbers mean many types. So most common are flame ionization detector. You would have heard this, right? Flame ionization detector, which is FID, and thermal conductivity detector, which is TCD. Okay. So this is also very important. Okay. Right. So this is about the components. Now let us go into the functional description. See, basically, gas chromatography is the separation of a mixture of components into a separate components. That's it. Is a separation of mixture of compounds into a separate components. That is the point. So by separating the sample into individual components, it is easier to identify and measure the amount of various sample components. I hope you agree, right? So by separating sample into individual components, it is easier to identify and measure the amount of various sample components. Okay. The sample is vaporized and injected during the injector system, right? Injected onto the chromatographic column and then separated into many components. So this is how it works actually, right? Okay, so the elution, there is one terminology called elution. It is nothing but extracting one material from another by washing with a solvent. That's it. So the elution is brought about the flow is brought about the elution, meaning the extraction of one material from another by washing with a solvent is brought about the flow of an inert gaseous mobile phase. There is a inert gaseous mobile phase. This elution is brought about the flow of an inert gaseous mobile phase. Okay, basically the extraction from one material from another. So this is happening or this is achieved by from an inert gaseous mobile phase. Okay, right. So in this aspects, actually, here the gas inlets comprises of carrier gas and sample. Okay, here, right? So injector has the function to inject this guy. Injector has the function to inject the same amount of sample each cycle. Okay. So column is a place where the sample is broken down. Okay. I'm just summing up, friends. Gas inlet comprises of carrier gas and sample. Okay, this injector has a function to inject the same amount of sample. Okay, sample each cycle. Okay, so column is a place where sample is broke down and separated. Okay, so detector is a place where the eluted sample eluted sample is measured. What is elution? Extraction of one material from another by washing with a solvent. So that eluted sample is measured. Okay. So that's about this functional description. Few more to add. Here we have seen this amplifier, right? Yeah, with the amplifier, the signal is getting amplified. So obvious, right? Yes. So data system actually determines the peak calculation and values are saved actually in this data system. Correct. So injection of sample quantity varies with the application. That is right? Obvious, right? So it varies with the application. And typically, this is very important. Typically, a gas sample taken in 170 microliters, whereas for liquid, it is between 2 to 5 microliters. This is very important, friends. Gas sample is taken in 170 microliters, whereas liquid sample, it's between 2 to 5 microliters. Very important point. Okay. So carrier gas, the mobile phase of a GC include helium, hydrogen and nitrogen, which are chemically inert. Okay. So here gas chromatographic separation occurs because of differences in position of adsorption equilibrium between the gaseous components of sample and stationary phases. Okay. So what I'm saying is here, the gas chromatographic separation occurs. How it is occur? Because of the differences in the position of adsorption equilibrium between the gaseous components of the sample and the stationary phases, right? Okay. So equilibrium is nothing but the temperature dependent, right? Yes. Hence the importance of selecting the stationary phase of the column here, right? Inside the stationary phase of the column and column temperature programming in optimizing a separation. So this is very important. So equilibrium is temperature dependent, and hence the importance of selecting a stationary phase uh, and of column and column temperature. Okay, so that we can optimize the separation. So that is the point. Okay. And what else? Yeah, finally, this is the detector response. You'll have a response like this, friends. So basically, the x-axis is the retention time, and y-axis is the concentration of intensity counts, basically here. As you can see here, is the retention time. Basically, it's an amount of time taken for the analytes to pass through the column and reach the mass spectrometer. So this is how actually we measure actually here. You see here, the concentration units, all these are there, right? Yes. See, this is the peak, right? Yes. This is how we do this measurement, friends. So again, to repeat, so this y-axis is the concentration of the intensity of the count. This is actually the retention time, amount of time taken for the analytes to pass through the column and reach the spectrometer detector. Okay, got it? Yes, that's all I have. If any questions, you can write to me. And yeah, as usual, I want your support. You know, last video was just viewed by very few people, so I'm a bit surprised actually. So that's why I decided to stop that. So this is, I hope this is will be useful. If it is useful and if you guys are supporting, then I can proceed further on this. Otherwise, that's it. I'll close and move on with the other aspects. Okay, thank you, take care, bye bye.